motion. A particle of mass 0.8 kg, rough plane, angle 28 degrees to horizontal, equilibrium. We have force T in this direction, 35 degrees horizontal. I mean from the slope, 35 degrees. And coefficient of friction 0.2. Find the least and greatest possible values of T. So first of all, we have to split the weight force. So the weight is vertically downwards, but we can split it into W cos and W sine. Just look at this right angle triangle. This is a right angle. If this is 28, this must be 90 minus 28, which is 62. So this is 62, so this is 62, and if this angle is 62, this is again 90 minus, so we get 28. So this angle is also 28. Now look at this right angle triangle. This is a right angle. The hypotenuse is W. If you are looking for the adjacent, we use cos. If you're looking for the opposite, we use sine. That's why we split it into W cos, W sine. For the T, same thing. Draw a right angle triangle. The hypotenuse is T. This length is the adjacent, so we use cos, and this length is the opposite, we use sine. So we split the T into T cos and T sine. And we also have the normal reaction force. Actually it is perpendicular to the slope and in this direction. Okay, so now for the possible values of T. So in the first case, when the T is really big, just like this, we have this component of T cos, and the friction force is therefore to the left because this is in equilibrium. So if this T cos 35 degrees is greater than W sine 28, this means the object will try to be accelerated in this direction. So that means the friction must be opposing that possible movement. So the friction must be down the slope to prevent the object from being accelerated up the slope. So if this is too big, the friction is down the slope. This is for the maximum T. And for the minimum T, so this time the T is really small. The T is really small, which means the T cos is really small. So it's like this size here, really small. So this means the weight sine 28 degrees down the slope is actually bigger than this T component. So that means without friction, the object will be accelerated down the slope. So if we want the object to be in equilibrium, the friction must be up the slope to help the T cos component so that they can balance the W sine, and it's in equilibrium now. Now in these two cases, we always have the same Y component here. Okay, so for the Y component, we have the same equation. So this is the Y component, so this is sigma F in this direction. This direction is perpendicular to the slope. So for the perpendicular to the slope, we have sigma F equals 0, which means this R plus this T sine must be equal to W cos. So if we rearrange, we get R equals W cos minus T sine. We have the normal reaction force, which is the same for both scenarios, both cases. And the maximum possible friction is mu R. That's the formula. Since we have R, we have the maximum possible friction. So again, this is the same for both cases, same expression, although the numbers will be different depending on the T, of course. So now we analyze the sigma F in this direction, which means it is parallel to the slope. Equilibrium means the sigma F equals 0. So for the forces up the slope, for the case of T max, we have only one force up the slope, which is T cos, and down the slope we have W sine and the maximum friction. So we replace the maximum friction with this guy here. So that's what we do here, and then we solve for T here basically. So we add this term to both sides. Basically we move it to the left, and then we factor out the T, and we divide both sides by the brackets, and we plug in the numbers. So the mass is 0.8, the W weight is therefore m times g, mass times gravitational acceleration. We replace the W with 8 basically, and then use a calculator. We get this. So this would be the maximum friction, tension. Now for the second condition, so this time, look at the diagram here. This time the T is really small. The F should help the T also up the slope to balance the W sign. So sigma F in this direction parallel to the slope equals 0. Down the slope we have actually up the slope first. Up the slope we have T cos plus F, and down the slope we have W sign. So now we are solving for T. We subtract this term from both sides, basically we move it to the right, and then we factor out the T, and we divide by the brackets, and W is again mg, and use a calculator. We get the minimum tension. All right, I'll see you again next time.